Good evening, students. We already discussed about the second order harmonic distortion in the classroom. We know the basic formulas for find out the distortion, second harmonic distortion, third harmonic distortion, fourth harmonic distortion, and total harmonic distortion. We should know the basic formulas. Okay. Now let's we understand some problems, or let's we solve some problems on harmonics. Okay. Before that, I would like to show you the expressions what we need to find out the total harmonic distortion. I'm going to explain briefly about distortion in amplifiers in the next classes, in future classes in the YouTube. As of now, let's we understand some problems on this harmonic distortion. Okay. We know B1 is the amplitude of fundamental frequency component. That is nothing but fundamental frequency is nothing but common frequency. That is nothing but 50, 60, whatever it may be. For example, 50 Hertz in the AC signal. But B2 is the amplitude of the fundamental second order frequency component. Sorry. B2 is the amplitude of not fundamental second order frequency component. Okay. Then B3 is the amplitude of the third order frequency component. Then Bn is the amplitude of nth order frequency component. Fundamental is different. Fundamental is nothing but very basic. Okay. Then B2 is nothing but second order. B3 is nothing but third order. Bn up to nth order we can calculate. For nth order, what is the formula? Nth order harmonic distortion denoted by Dn, that is nothing but distortion n is equal to up to nth term. N is equal Dn is equal to magnitude of Bn divided by magnitude of B1 into 100. For second order harmonic distortion, n is equal to 2. We need to consider n is equal to 2 because second order. What will going to become the formula? You need to replace this n is equal to 2. Percentage D2 is equal to B2 divided by B1 into 100. Likewise, you need to substitute n is equal to 3 for third harmonic. D3 is equal to B3 divided by B1 into 100. For total harmonic distortion is equal to whole root D2 square plus D3 square plus D4. You can take D4, fourth harmonic distortion. Otherwise, you can stop up to D3, that is nothing but third order distortion. Plus up to nth order, you can substitute and put into this total harmonic distortion formula. D is equal to root D2 square plus D3 square plus D4 square plus up into 100. Total into 100 we need to consider. D is equal to total harmonic distortion. Okay. Now let's solve some problems on this basic formula. Sometimes they will going to ask this type of question. Okay, so that's why I'm going to solve four problems. Let's we understand one by one. Okay, students, calculate the harmonic distortion components. Harmonic distortion components is nothing but what, students? D2, second order harmonic distortion. D3, third order. D4. Likewise, we need to calculate. We don't know how much we can calculate. Let's we understand here how much we can calculate and that. For an output signal having fundamental amplitude of 2.5. What do you mean by fundamental? Fundamental amplitude is nothing but B1. Second order harmonic amplitude 0.25. That is nothing but what, students? Amplitude. B2 is nothing but 0.25. Third order harmonic of 0.1, B3 0.1, and fourth order harmonic amplitude of 0.05 volts, and also calculate the total harmonic distortion, that is nothing but percentage D is equal to, they will going to mention amplitude, how much they will going to mention B1, B2, B3, B4 also. So up to we need to calculate D2, D3, D4. D2, D3, D4, up to we need to calculate up to 4. From 2, 3, 4. Okay, students, 2, 3, 4. distortion we need to calculate. That is nothing but second order, third order, fourth order. We have fundamental. This is nothing but fundamental. B1 is nothing but a fundamental. B1 is nothing but a fundamental. B1 is nothing but a fundamental, very basic one. This is the fundamental amplitude. That is nothing but a 2.5. Okay, 2.5. Next, B2 is equal to 0.25. B3 is equal to 0.1 as per our question. B4 is equal to 0.05. Now, let's we calculate from D2, second order distortion. D1 is not there, okay? D1 is nothing but a fundamental like B1. So we need not to calculate, we're not able to calculate D1. So let's we calculate from D2, second order distortion. This distortion is very, very important. Second order harmonic distortion is very important. Okay, D2 is equal to B2 divided by B1. What is the B2 value? 0.25. 0.25 divided by 2.5. B1 value 2.5. Substitute and get the answer and do multiply and do multiply into 10. Sorry, 100. That will going to become 0.1. That is nothing but into 100 madre 10% we will going to get. Okay, D3. How to calculate D3? B3 divided by B1. D3 value is nothing but 0.1 divided by B1 value is nothing but 2.5 is equal to 0.04. That is nothing but we need to multiply into 100. That is nothing but 4% will going to come. D4 is equal to B4 divided by B1 is equal to B4 is nothing but what, students? 0.05 divided by 2.5 is equal to 0.02. That is nothing but we need to multiply into 100. That will going to become 2%. Okay. Now, percentage D we required. What is the formula for percentage D? Root D2 square plus D3 square up to how much they will going to mention? D4. So D4 into 100. Sorry, this is nothing but into 100, 100. Substitute the value and get the answer like 10.95 for total harmonic distortion. This is how we need to solve the problem. Sometimes they will going to ask this type of very easy questions in the semester end examinations. Okay, now let's we calculate. Second problem. Let's solve some second problem. Okay, calculate the second order distortion for an output waveform having measured values of VCE is minimum is equal to 2.4, VCEQ is equal to 10 volts, VCE max is equal to 20 volts. Okay. Now, with the help of three parameters, we can calculate B1 and B2. How to get this formula B1 and B2? With the help of some derivations. Okay. I will explain the derivation in the YouTube in future classes, but already we done in the classroom. Okay. B1 is equal to BCE maximum minus BCE minimum divided by 2. So, okay, substitute the values like BCE maximum is nothing but 220. BCE minimum is nothing but 2.4 divided by 2. That will going to become fundamental amplitude will going to become, students, 8.8. B2 is equal to BCE maximum, BCE maximum plus VCE, VCE maximum plus VCE minimum minus 2 VCEQ divided by 4. Substitute the values like VCE maximum, that is nothing but 20 plus VCE minimum, that is nothing but 2.4 minus 2 into VCEQ, that is number 10 divided by 4 is equal to 0.6. Okay. Percentage D2 is equal to B2 divided by B1 into 100, that is number 0.6 divided by 8.8 into 100. That will going to become 6.1818. Okay. What is the question they will going to mention? We need to calculate second order harmonics. Okay. Second order harmonic calculate ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ we need to find out B1 and B2 because this is the formula. So that's why first we need to find out B1 and B2 and substitute the value and get the second order distortion. If in case they will going to ask sometime calculate third order distortion, in that time you need to calculate B3. Then you need to implement the formula B3 divided by B1. You will going to get the third order distortion. So this is how we need to solve the problems on harmonic distortion. Thank you one and all. In the next video, let's discuss some more two problems on this harmonic distortion. Thank you so much.